There's also different ways of computing loans. We have seen amortized loans in earlier example. You buy a car and you pay off your loan in equal installment over a period of time. Right? And most of the business loans are like this. So we have already shown that how to compute the equal payment based on the interest rate that we have. Here's another loan which are popular for furniture and appliances. It's called add-on loan. It looks simple. You have a simple interest rate, and you can use the interest rate to compute the total interest that you need to pay, and then you add it to the principal and divided this amount by number of payment periods. Okay, it looks simple, but is it better than amortized loan, or is it worse? Right? Is it better or is it worse? If you don't know, people may offer you one or the other. Once you choose it, you feel that, oh, I feel that this one seems to be better, but in fact it's a lot worse, then you are in trouble. Let's look at these two. Amortized loan, we have seen this already with the identical example here. You borrow money for buying the car, and this amount needs to be paid back over 4 years period, and the APR, annual percentage rate, is 8.5%, and it is compounded monthly. The interest period is month by month. So we can take this present value 20,000 given P, find A, and the monthly rate will be 8.5% divided by 12, and for 48, and you will get 492.97. So that's what you will pay every month for 4 years. This is amortized loan, which you have seen before. One question which we may encounter for this kind of loan, that is, after certain amount of time we decided to discontinue this loan, so we need to pay back the rest of the amount that we still owe. But how do we calculate that? That's a question. How do we calculate that? In this example, after the end of the 25th month, we decide after we pay the 25th month, we decided to pay back the rest of them in the lump sum payment. So how do we come up with the number that we need to pay back? I think this cash flow diagram helps us to understand how to compute very clearly. The amount that we need to pay back should be the amount of money. Okay, the amount of money at that time, which is of the equal or equivalent worth of the rest of the payment. Because we are not going to pay them anymore. So we need to convert these the rest of the payment to this point, the end of the 25th month. Okay? Find the equivalent value and pay back at that time. So it's quite relatively because we have A, right? So given A, we want to find P, and we know the monthly interest rate, and we know from the 48th month until 25th month, we have 23 periods. So we just need to use given A, find P, multiply by A with these two parameters. We can come up with the coefficient and multiply by 492. So we know that at that time we need to pay 10,429, which is equivalent to the rest of the payment, in the yellow box. Okay, they should be equivalent because you are paying back the rest of the money that you should pay for over the rest of the time in one lump sum payment. Okay, so it's quite straightforward that you can compute that. Okay, later we will look at the generalized form. But basically, whenever we do something, it has to be logical. We say we want to use a certain cash flow to replace other cash flow. They need to be economically equivalent. Okay, so that's why we talk about equivalence earlier on. Here we can see the example very clearly. We just need to find the equivalence, then we know how much we need to pay at that time. For the add-on loans, as I try to hint that add-on loan is difficult to see its effective interest rate. Here we have an example. If you borrow 5,000 for 2 years at an add-on rate of 12% with equal payment due at the end of each month. Okay. So based on the formula we saw previously, we will compute the interest that we need to pay. So 12% by 5,000 by 2 years, so we'll pay 1,200. Okay, and we take 5,000 plus 1,200, which come to 6,200, and divided by 24 months. 24 months. Again, this is given by design. Okay, so every month you are paying 255.33. Okay, well, again, the computation is very simple, and well, the add-on rate is 12%. Well, maybe we are paying 12% per year, or maybe a little bit more, maybe 14, 15% effective rate for this kind of payment installment arrangement. Think about it. We are paying 258.33 per month over 24 months. What kind of interest we are paying? What do you think? Are we paying higher, much higher than 12 or lower than 12? Let's look at this, 258.33 over 24 months period. We got 5,000. We pay out 258.33 24 times. And if we write up the equivalence, okay, write out the equivalence. What we don't know is I, right? We want to compute the, and we can compute the coefficient. And got the coefficient is 19 times of 258.33. So by try and error or interpolation, we found out that we are paying 1.79 around 1.8% per month, which is the effective interest rate per month. If we multiply that by 12, we got 21.57 per year nominal rate. If we use the right way to compute its effective annual rate, you will find that in fact we are paying 23.84% per year for the interest we are paying, meaning that the effective annual interest rate is 23.84%, whereas the add-on interest, which was shown, is only 12%. So we need to be very careful. We need to understand the effect of the computation and the effect of the compounding interest. When we compute this effective interest rate here, now we realize that the add-on way to pay for the interest, because it considers the whole amount for the whole period rather than having this amortized behavior. So the interest we are paying will be a lot higher than amortized loan, right? So it's almost twice. Another very practical example that we'll encounter very often, that is between buying or leasing. Of course, for buying and leasing, there could be a lot more factors that we can consider. But just assume that in this case, buying is just you borrow money and buy the car and trying to pay back the money you borrow over a period of time. For leasing, it's just that right from the beginning, you are paying for the car you lease monthly. Until the end, you need to pay some additional fees. Okay, these are the different series of cash flow, and when we want to compare which one is better, then we need to compute carefully, taking into consideration of the financial items as much as one can. Maybe let's just use this more clear tabularized data to compare these two options. The first one is so-called debt financing, basically borrowing money to buy the car, and the second option is just borrowing money for paying it's called lease financing. So assuming that the price of the car are the same, for buying the car you need to pay some down payment. You are paying this at 3.6%, and your monthly payment was given based on 3.6%, and the duration is 36 months. And in the end of your usage, after 4 years, you can sell it, and let's just assume that the resale value is 8,673. And in the beginning, when you sign up for getting the car, you need to pay cash 2,000. That's one series of cash flow. Option 2 is lease financing, meaning you get the car, which worth a lot, but then you just pay for the lease, the monthly payment, 236.45 for 36 months. In the end, there's a fee that you need to pay, $495, and in the beginning, you have to pay for the lease, which is $300, and so the cash due at signing is $731.45. Okay, so these are the we can convert them into cash flow diagram, which is, as I said, again and again, it's very easy to visualize and very easy to understand. It helps us to make the computation easily. So what we are trying to see is to compare these two series of cash flow and see which one present a lower cost. So for the top one and for the lower one, you can tell that it's quite easy to just convert them into a present value. Okay, so we have for option 1 we have basically 26 equal payment, and at the end we get salvage value from selling the car, and in the beginning we pay 2,000 down payment, so it can be easily converted and add up. The second one will be very similar. The payment in the beginning at time 0 is a little bit different. You can just keep it there. But for the rest of them, most of them are 236.45, except the last one is 300. We can compute and adjust. There are many ways to compute. Basically, a lot of equal payment, which can be computed very easily. So you can come up with the formula and add them together. And in the end, we found that debt financing, that is buying the car and selling the car with a salvage value, the total debt will be a little bit lower than 7,000. If we use leasing, and the result will be over 8,500. Okay, so because we take both of the series of cash flow to the present time, the comparison is reasonable. However, there are other issues that we did not mention here. I think if you are having a business, if you are leasing the car, you can make the car a company car, then you get tax break. Your expense, your rental fee can be considered as the expenses of your business expenses, so you can reduce your tax. So that will have additional benefit, which is not considered in this example. But based on the data that we have, clearly debt financing is better than lease financing in this particular case. In the end, we want to look at a generalized form for amortized loan. We know amortized loan through the example, a car loan, auto loan, that we explained twice already. But what we are trying to do is to come up with a generalized form to compute different values that we may be interested in. For example, one thing that I think a lot of you may be interested in knowing is, although we do this equal installment over a number of periods, however, for each payment, we are paying some interest based on what we owed in the previous period, and also return some amount of principal. So for a specific payment, how much is the payment is for returning the principal, how much of it is for paying interest, that we may be interested in knowing, and that can be computed too. So that's what we are trying to do. So there are a few notation that we need to know. You know that for amortized loan, after we paid an installment, then along with that payment, some principal was returned. So the amount of the principal that we owed become smaller. So we'll use that principal to multiply by the interest to come out with the interest that we need to pay for the next in the next payment, and the amount of equal installment minus the interest that we pay will be the principal that we return. Right? That's straightforward. So that with that principal, then as soon as we know the remaining balance, then we can compute the next interest and compute for the next payment the part that we are paying back the principal. However, how do we know the remaining balance at a specific time? In fact, it's not that difficult. You can imagine the series, and remember earlier we have already computed the remaining amount that we need to return if we want to return the rest of the payment in a lump sum payment, right? So at the time we say that the amount that we need to pay will be equivalent to the rest of the payment together, economically equivalent to the rest of the amount, the rest of the installment that we altogether that we will pay. So that total amount will be what we still owe. That is what we still owe. Right? So we'll pay them back. Or we can move from the from. If we are at a certain point after paying the installment, then we will know how much we have already, how much principal we have already paid back, right? Then we use the total principal, subtracting that value, then we get the remaining amount. So there are two methods to compute this remaining amount. Once we have the remaining amount, we can compute again the interest for next period, and then we can compute the return principal for the next payment. So basically, after going through this chapter, we talk about the interest rate extensively, and you can see in many different examples when you have an interest rate, it doesn't really reflect the true interest that you are paying, the true interest rate you are using. So you have to understand all the terminologies, understand the meaning of them, and understand how to use them so that you can assess the impact of that interest correctly.